All right, guys, let's finish up this lesson. All right, so for number 8, we're finding the 7th term. So we're going to take a sub n equals a sub 1 times r raised to the n minus 1, where I'm looking for the 7th term. My first term is 3. My ratio, if I do a little bit of math, I'm multiplying by 6 raised to the 7 minus 1. So I did 36, no, not 6, let's back that up, I made a mistake. This could be 12. 36 divided by 3 is 12, 432 divided by 36 is 12. All right, so let's go to our calculator. We're not doing that math, so I'm going to type in 3 times 12 raised to the 6th. Do a little bit of math. And if I keep going out, 8, 9, 5, 7, 9, 5, 2. 8,957,952. All right, so we got to figure out that ratio. All right, so for number 9, we did a problem similar. I'm looking for the 6th term. I'm looking for this one. I'm given the 3rd. I'm given the 5th. So I'm going to change it to the 1st and the 3rd. Because truly, I'm not looking for these. These two aren't important. So I'm going to write 64 over 27 equals 16 over 3. My ratio, which I don't know yet, to the 3 minus 1, because now I'm dealing with 3 terms. I'm dealing with these 3. All right, so I'm going to multiply by the reciprocal. Do some cross canceling. We get 4 ninths equals r squared. Next, and this is where, if we were in class, I'd let you make this mistake and keep asking you for what it is. But when I square root the right side, I have to plus or minus square root the left side. Because remember, when you get rid of a square, you have to plus or minus. So my ratio is either going to be a positive or a negative 2/3. We don't know which one. It could be either, and I'll show you why in a second. So when I take my 64 over 27 and multiply it by plus minus 2/3, I'm going to get a positive or a negative 128 over 81. The reason this is a plus minus, because when we go back, way back at the beginning, when my ratio is negative, every other term was negative. So if this one was negative, that one could be negative, and that one could be negative. I don't know. Every other term on this problem could be negative if my ratio is negative, or it also could be positive if my ratio is positive. Since I'm missing every other term, I need to make sure I have a plus or minus. And that all comes down to, we say it all the time, when you cancel an even root, by square rooting it, fourth root it, eighth rooting it, you'll always get a plus or minus. All right, next formula. The sum of a finite geometric sequence or series. The sum S sub n, let me get rid of this because it's always a little bit confusing. S sub n equals a sub 1 times 1 minus r to the nth divided by 1 minus r. If you have an old calculator, I would probably not use it on these. It gets a little confusing. It's easy to make a mistake. I would use a fancier calculator that will give you the fraction by hitting alpha y equals enter, or I would use Desmos. All right, we don't want to get into how to use this other one because it gets a little bit to be much. All right, a sub 1 equals, or a sub 1 times 1 minus r to the nth divided by 1 minus r. All right, so what I need to be able to find the sum of a geometric series, first term, ratio, number of terms. Those are the 3 things I need. All right, so given this first problem, I want the sum from n equals 1 to 9 of negative 2 raised to the n minus 1. The sum from n equals 1 to 9 of negative 2 raised to the n minus 1. All right, so I need the first term, the ratio, and the number of terms. But I can look at this to get my number of terms. I do my top number minus my bottom number, and I add 1. That was our rule. Top minus bottom, add 1. So my number of terms is 9. My first term, I'm going to plug a 1 into here. So I'm going to say negative 2 in the parentheses raised to the 1 minus 1, which is negative 2 raised to the 0, and anything raised to the 0 power is 1. All right, so there's my first term. Let's go back. My 9 is my number of terms. Now we need to get a ratio. Without looking at this, we can't get a ratio. So what I'm going to do is I'm going to find my next term. I'm going to plug in 2. And I get negative 2 raised to the 2 minus 1. Which is negative 2 to the first, which is negative 2. All right, so I'm going to find the second term. Since I have the second term now, to get my ratio, I'm going to do my second term divided by my first term and get a ratio of negative 2. So what I did is I found my number of terms by doing the top minus the bottom, adding 1. That's how we figured out. Get my first term by plugging in 1. Got my second term by plugging in 2. I divided those and got my ratio. So now my sum of 9 terms is going to equal 1 times 1 minus my ratio, negative 2 raised to my number of terms, which is 9, divided by 1 minus my ratio. I'm going to plug in what I have. Now I'm going to go to some device. I'm going to plug it in. Hit enter and get 171. So what we found is if I plug 1, get a number. Plug in 2, 3, 4, 5, 6, 7, 8, 9. Plug all these numbers in and get these answers and add them together. All of those are going to add up to give you 171. That's what we're finding. All right. Let's do another one like that. So if you want to pause it, work this one on your own a little bit. Find me the number of terms. Plug in the bottom number to get your first term. Plug in the next number to get your second term and divide and get your ratio. Top minus bottom plus 1. My first term. I plug in 0 to get your first term. To get my next term, my next term is going to be 8/3. I'm going to plug in 1. 4/3 to the first is 4/3. 2 times 4/3 is 8/3. Now to get my ratio, 8/3 divided by 2, which is 8/3 times the reciprocal. Cross cancel. And I get a ratio of 4/3. Find the first term, find the next term, find the number of terms, and once I get my first and my next, that helps me find my ratio. So I'm going to take the sum of 16 terms as my first term, 2 parentheses 1 minus my ratio, and I'm always going to put parentheses around it. Ugly. But we're not going to do that on our head. We're going to have to use some device to do that. So plug into Desmos probably. And this one doesn't, my numbers are so big it won't give me a fraction, which is fine. I'm around the 3 decimal places. Forget that. I mean, I want fractions because we start with fractions. But since it won't give me the fraction, that number's too big, I'll accept the decimal. So, find the number of terms, top minus bottom plus 1. Plug in the first number to get your first term, plug in the next number to get your second. Find your ratio. All right, but we're going to make this a little bit easier. If, when you plug this bottom number into the exponent, it becomes 0. That's a good thing, because if that's the case, your first term is going to be the number in front of the parentheses. The number in the parentheses is going to be a ratio every single time. That's how it's going to work. If I go back to here, when I put 1 up to here, 1 minus 1 gave me a 0 for my exponent, which is good, which means this number is my ratio, which we said it was. And then the number in front of here, which is a 1, is your first term, which we said it was. If you plug this number in and you don't get a 0, you have to do the longer steps. But if you plug this number in and you do get 0, ratio first term every time. You go back to here. Ratio first term because I got an exponent of 0. All right, so that's how we do it. So these get a little bit uglier, but with Desmos it shouldn't be an issue. All right, the last part. All right, this is for an infinite geometric series. To find the sum of an infinite geometric series, which means it goes on and on and on and on forever, we're going to do first term divided by 1 minus r. My first term divided by 1 minus my ratio. All right, as long as my ratio is between -1 or 1, which is a number that's going to make my numbers get smaller, like a half, 2/3, 3/5, 0.9, -0.73. Okay, as long as it's between -1 and 1, we can do an infinite geometric series. Okay, but if it doesn't get smaller, we can't. All right, so what we're going to do is we're going to talk about the idea of this. All right, we're going to talk about why it works and how it works, and then we're going to do the math. All right, so what we're going to do is we're going to list out 7 or 8 numbers. We're going to list out the first 7 or 8, but it keeps going forever. So I can't get all of them, but we're going to get an idea. So I'm going to plug a 0 up here. Plugging a 0 in, 1/2 to the 0, is a first term of 1. Now I'm going to plug in 1, 2, 3, 4, 5, and 6 also. So 1/2 to the first is 1/2. 1/2 to the second is 1/4. And if I keep going, and I'm just going to keep writing a bunch of them. I get this. Okay? What we need to recognize is happening. If I go from 1 to 1/2 to 1/4 to 1/8, my ratio on this problem is 1/2. Because when I plug 0 into here, I get an exponent of 0. Here's my ratio. Here's my first term, which is 1. All right, since my ratio is 1/2, my numbers, as I keep going, are getting smaller and smaller, from 1 to 1/2 to 1/4 to 1/8 to 1/16. What's going to happen is, as this keeps going on and on and on and on forever, the number I'm adding is getting smaller and smaller. 0.5, 0.25, 0.125. Okay? It's getting smaller and smaller. And at some point, I'm going to be adding a number so small that it's pretty much going to be 0. Thinking if we start with 1 pizza, and I give it to you, it's all yours, you get to eat it, you get the whole pizza. But if I take that pizza and you have to share it with one other person, so there's 2 of you guys eating it, you get half of it. If you have to share it with 3 people, so there's 4 of you, if 4 people are sharing it, you get 1/4. 8 people, you get less. 16 people, you get less. As I keep multiplying by 2 and taking half, at some point, if I keep cutting your piece of the pizza in half and in half and in half and in half and in half, you're not going to get anything. you're going to get this little bitty piece of crumbs. All right? So that's what's happening. If you're taking half of something and you keep taking half forever, that number is going to get so small it doesn't make a difference. And that's what we have to have. We have to have a ratio that fits between -1 and 1. If it doesn't, you can't do it. All right, so if I keep adding all these numbers together, my number is going to get so close to a value that we're not going to understand the difference. So now going to the formula. My first term divided by 1 minus my ratio. 1 divided by 1 minus a half, which is 1 divided by a half, and I'm going to multiply by 2. And I'm going to get an answer of 2. All right. It's going to be so close to 2. It's going to be 1.9 repeating forever and ever and ever and ever and ever, millions and millions and millions of numbers, that we're going to call it 2. It's not really 2, but it's close enough. Because this number that we keep adding is going to keep getting smaller and smaller and smaller. So the idea with this, your ratio has to be between -1 and 1. It has to be a number that makes my numbers get smaller. Doesn't have to be a fraction. I mean, it can be a fraction, but it doesn't. All fractions don't make it get smaller. 1/3 gets smaller. 2/5 gets smaller. 5/2 gets bigger, and it doesn't work. So your numbers have to get smaller. All right, so I'm going to look at this next one, number 13. I want the sum from n equals 0 to infinity of 2 times 2/3 to the nth. All right, so when I put my 0 in here, I get 2 times 2/3 to the 0. Oh, there's my 0 exponent, so this is my first term, and that's my ratio, automatically, because my exponent became a 0. So my sum is going to be 2 divided by 1 minus 2/3, 2 divided by 1/3, 2 times the reciprocal, and I'm going to get 6. My ratio fell within my standards between -1 and 1. Multiplying by 2/3 makes my numbers get smaller. So it's good. So if I find the sum from n equals 0 to infinity of 2 times 2/3 to the nth, I'm going to get an answer of 6. All right, try 14. Pause it if you need to. I'll give a couple seconds before I start. But go ahead and pause and take it as far as you can. When you get an answer, see if your answer looks good. All right, so when I do this, my ratio comes out to be 3/2. My first term is 3. If I don't see it, I'm going to do my math and get a sum of -6, which should make you question it. I don't know where a negative number would come from. The math you did is right, but if we go back, is 3/2 between -1 and 1? Is 1.5 between these two numbers, which it's not. So we can't take the sum of a finite geometric sequence if my ratio is larger than 1. All right, because 3/2 is multiplying by 1.5. If I keep multiplying by 1.5, my numbers keep getting bigger and bigger and bigger and bigger, and I can't get an answer of 4. I'm not going to get a good answer. I'm going to get an answer of infinity because it keeps going up. So when you do this, and once you get the ratio to be 3/2, which is not between -1 and 1, you stop. 2/3 fits in that interval. So we do it and get an answer of 6. 3/2 does not, so I'm not going to get an answer of -6. I'm going to say it has no solution. All right, that's the rest of the lesson. If you have any questions, come to tutoring on Friday. If you get this before Friday, or send me an email.